All right. So thanks a lot, Thijs, for that lovely introduction. So I'm Tom van Cutsem. I'm going to talk to you today about ECMAScript 2015, also known as ECMAScript 6. So that's the latest standard version of JavaScript. And so I'm not going to just give you a talk about all the things that are new in ECMAScript 6. You can read all about that on the web. I'm going to do a bit of that, but I also want to give you some context on how this standard came to be, what's sort of the history behind it. Okay? So in the first part of this talk, I'm going to talk about JavaScript's origins and the very long road that led to ECMAScript 6. In the second part of the talk, I will give you a brief tour of some of the highlights of ECMAScript 6. And then in the third part, I will talk about how you can start using ECMAScript 6 today, because since it's a fairly recent standard, it's actually been ratified only in June of this year, not all browsers, for instance, have upgraded to that latest standard. So there's sort of we're in a transition period, and I will help you sort of navigate that transition period. And then finally, I will give you a glimpse of what is after ECMAScript 6, okay? What's next? So JavaScript's origins and the road to ECMAScript 6. So as maybe some of you know, JavaScript was invented by Brendan Eich back in '95 when he was an intern at Netscape. So Netscape, one of the early browsers, they realized they needed a little scripting language to do simple stuff like form validation and so on. And Eich, over the course of a few weeks, actually hacked together that first JavaScript interpreter, which was originally actually called LiveScript and then rebranded to JavaScript because of a marketing deal with Sun. And then later, it got standardized as ECMAScript, ECMA being the name of the standards organization where it got standardized. And so when Netscape released that, Microsoft fairly quickly realized that they needed something similar, so they copied JavaScript. They sort of reverse engineered it because at that time there was no spec, and they put it in Internet Explorer, and sort of they copied it warts and all, meaning that JavaScript, it's not a language that had gone through like a testing phase, or like we just heard Joss talk about, like the internal adoption. It wasn't sort of ready for prime time yet, but it was out there. It got copied. Now it was in true browsers, and by that time it sort of became too late to sort of fix all the bugs that it has, or the flaws that it has. And so for a very long time, most developers, they would look at JavaScript and say, well, I'm not going to write any sort of decent piece of code in this. I'm not going to touch that. For a very long time, that was sort of this perception. And I think things started changing only in 2007, 2008, when this book appeared on the scene, JavaScript, The Good Parts, which was written by Douglas Crockford back when he was a senior architect at Yahoo, where he basically called out that, okay, JavaScript has all of these words, but it also has, if you just look at the core language, it has functions, higher order functions, these nice object literals. You can be quite productive if you just know, what parts to stick to. Also, it's the object literal syntax of JavaScript that led Crockford to invent JSON, which by today is one of the most popular data interchange formats. So what is ECMAScript? It is the standardized version of JavaScript. It is the version that runs more or less compatibly across all the major browser platforms. So as you may know, each browser has, as a component of it, a browser engine or a JavaScript virtual machine. They go by different names. Very popular ones are V8, which is the Google, the engine that powers Google Chrome, SpiderMonkey, which powers Firefox. In fact, Opera earlier this year decided to switch to V8 also. Previously, they maintained their own engine. And of course, there is an engine that you may have heard of called Node.js, which is a server-side JavaScript engine. It doesn't run in a browser. But in fact, Node basically adds a number of things to V8. So V8 is the sort of the core that drives the Node.js engine. And today, Node is really one of those things that has grown exponentially over the last years, with today more than 170,000 open source libraries available for it on its package management system. So ECMAScript is being specified by a committee, a technical committee called TC39. You can think of it as the JavaScript Standardization Committee. Who is in that committee? It's mostly representatives from major internet companies, Google, Facebook and so on. There are browser vendors, so Mozilla is there, for instance. Web organizations, popular JavaScript libraries like jQuery, for instance, and members from academia, which is how I originally got involved in the standards effort. And they meet bi-monthly to discuss the open issues and to drive the features. And the actual thing that this committee produces, the actual output, is the ECMA 262 specification. So it's a big handbook, and it's primarily intended to be read by the people that implement the JavaScript virtual machines. Okay, that's the target audience of that spec. If you're a JavaScript programmer, this is not really, it wasn't really designed to be read by JavaScript programmers, but rather by, let's say, VM implementers, if you will. So that's really its key purpose. So the editor of the ECMAScript 6 spec was Alan Worsbrock, who maybe many of you know. He's also a member of the Uppsala community. So he really drove that effort as the technical editor. But you shouldn't think of ECMAScript being this top-down design by a committee. There's actually a fairly fair amount of community involvement. So all of the discussions are being held in the open. There's a ES Discuss, which is a public mailing list. Throughout the year, there are discussions, constant discussions, proposals about the language. The meeting notes of these bi-monthly meetings are completely published out in the open. You can go and read them. So it's a fairly transparent process as far as standards organizations go. So ECMAScript 6, what's sort of the history behind this? So let's go and look at how this spec has evolved over the years. So JavaScript got standardized fairly early on in 97 already, first edition, and then received 2 minor updates in 98 and 99. But really, those updates were quite minor in terms of new language features being introduced. I think 3rd edition introduced try-catch statement, which wasn't there before, but other than that, no real big semantic changes. So then after that sort of initial consolidation of what was out there, the committee started to work on a sort of bigger improvement of JavaScript. They realized that JavaScript, of course, was a fairly small scripting language. If you compare it to other languages, it lacked a lot of features. People wanted classes, people wanted modules, people wanted namespaces, people wanted optional static types, and so on and so forth. So there was this large effort to work on a 4th edition of the spec, which over the years actually sort of broke down in a couple of ways. In one way, that it was getting too big, too fast. Okay, the language was getting too complex. Language features were not always coherent, and importantly, JavaScript, because of its many sort of design flaws it inherited from its origins, there are really a lot of features that had ill-defined semantics because of features like the with statement or eval and so on, which could really sort of even mess up your scoping. Okay, so a subgroup within the committee decided that what they thought was the right way forward was to, rather than grow the language significantly based on this sort of flawed basis, that we should fix the basis of the language first and then start from a more solid foundation and grow the language from there. And for a long time, the committee was in deadlock because they couldn't reach unanimous agreement on how to move forward. And that changed in 2008 when they had a meeting in Oslo, and that meeting is now referred to as the Harmony meeting. You may have heard of ECMAScript Harmony. Well, that's where the name comes from, where they basically agreed again on how to move forward as one committee. And the agreement was that indeed they were going to drop the work on the 4th edition, refocus on the flaws that were in ECMAScript 3, maybe also consolidate on some features that got standardized along the way. So fix the language first, release that, and then when that gets released, we can start thinking again about more complex language features. And indeed, that is what happened. So just a year later, end of 2009, we had the 5th edition of the spec, which was, it had some new language features, but really not that interesting from a point of view of a developer. Actually, the most important feature, I would argue, was a feature called strict mode, which is an explicit opt-in. You would have to explicitly opt into this strict mode subset of JavaScript. And when you work in that subset, the language becomes a lot saner, especially in terms of scoping behavior. When you're in strict mode, you have real lexical scoping. You can't have tricks with eval or the with statement to mess up your static scope at runtime, to name just one thing, okay? So strict mode formed this sort of cleaner basis to grow the language on. And then, so indeed, as was agreed at the Harmony meeting after the 5th edition got released, work started again on growing the language with new language features, but now at least they had sort of cleaned up the base language. And so that was actually, during that period from 2009 up to 2015, many features were vetted by the committee. A lot of features also were just taken out of the experience we had with 4th edition and sort of revising them. But there were also new features that entered the picture and so on. And so in June of 2015, the 6th edition of the spec got released. It's now rebranded ECMAScript 2015. Why is that? Well, so as you can see, there are fairly big gaps between these releases of the different editions. So actually, 4th edition never got released. They just, because it had all these connotations, they just didn't release it. But 5th edition, 6th edition, they're like a many-year gap. And the committee wants to change that in the sense that they want to go to a more yearly release model where now every year they just release an update to the spec. And if there's a language feature that is deemed ready, it goes in. If there's a language feature that is deemed not ready yet, it's just postponed over to the next year. Okay, so we're going to this yearly release train model, which is why the 6th edition is called ECMAScript 2015. Okay, so let me now give you a brief tour of some of these features in that latest specification. Now, ECMAScript 6 is quite a big spec. So if you look at the time period we had to put in new features, it's a long time period. There's many features that are being added. And I did the page count. I took the ECMAScript 5.1, which is the latest, what was the previous latest standard, which has 258 pages. And then I counted the number of pages in the PDF of ECMAScript 6, and it's a factor of 2.2 bigger. Okay, so JavaScript has just become twice as complex. You can summarize it like that. So I don't have time today to cover all of the things that are in there. There's many interesting features in there. So I'll just focus on a few things. The big ticket items, the things that most developers will encounter when they do ECMAScript 6 programming, classes and modules. Okay, and then I will focus on some features that have to do with control flow, improving control flow, iterators, generators, and promises. So, classes and modules. So, JavaScript is a prototype-based language. It doesn't have classes, but many developers, of course, very soon realize that there are patterns so that you can do class-based programming in JavaScript anyway, even if you don't have classes as such. And there's this whole sort of pattern that you need to use to be able to use functions and objects as classes and constructors in JavaScript. I don't have the time to go into all detail. But the thing is, even though it can be done, if you're coming from a language like, say, Java, and you read this code, it's not immediately clear that it's actually encoding a class pattern. So in ECMAScript 6, you can just refactor this code on the left and have a class definition with a constructor definition and then method definitions. And to any developer coming from Java or C# or so on, this should look extremely familiar. Okay. Now, interestingly, even though ECMAScript 6 has a class syntax, it has no notion of classes at runtime. In other words, you can almost think of this as sort of syntactic sugar, because at runtime you will still have, even though point is declared as a class, at runtime it will still be a function. Okay, so it's not like in Java where you can ask an object for what is your class. Okay, it's still, so that means that as a developer you still need a good sense of the actual runtime model of JavaScript. But it's okay. It makes the intent of the code a lot more explicit. There's another benefit, which is that in ECMAScript 6, all the methods or all the code that you write as part of a class definition is implicitly opted into strict mode. So you don't have to manually add that opt-in into strict mode. If you use classes, you are in the sane mode of JavaScript, let's say. Okay. Now, modules. So that's really another sort of big ticket item for the community, because for a long time, in JavaScript, the way you had to link up multiple modules or multiple script tags on a page was quite horrible. The only mechanism you had to do linkage was to read from and write into the global object, the global scope. So if you have like top-level variables in a script block, these will actually implicitly be properties of the global JavaScript object, and that allows other script tags to sort of read those variables and then do things with them. Okay, and so that works to a certain extent. Of course, you get global scope pollution. People have come up with all sorts of ways to mitigate that. Also, all sorts of informal standards on how to do modules in JavaScript. So the committee decided once and for all that we would have modules as really part of the core language. And in a module definition, which you can sort of, this is actually sort of a provisional syntax because the actual HTTP or HTML, the way it interfaces with HTML is not yet fully standardized, but the idea would be that you could annotate a script tag as a module, and then in that script tag, top-level variables like x over here are actually just local to that script tag or local to a file if this would be in a separate file. And the linkage between the different script tags or different modules is through the means of explicit export and import keywords, which you might know, for instance, from Python. And one of the benefits of having these explicit imports and exports is now at the import side, for instance, your VM can actually check whether the things that you are importing from this library actually exist in that library. Okay, so you get a better form of, let's say, not really static checking, but at least load time checking, if you will. And again, all the code that you write as part of modules in ECMAScript 6 is implicitly in strict mode, in this saner subset of the JavaScript language. Okay, so the other thing I wanted to focus on is a few sort of abstractions that all tie together that relate to control flow. So the first one being iterators. So of course, most of you will know iterators, for instance, from a language like Java. Now, in JavaScript, there is no sort of standard notion of an iterator because, yeah, it's not a typed language, so you don't need a standard iterator class. But that doesn't mean you can't do iterators in JavaScript. For instance, say I want to write a function called Fibonacci that returns an iterator that I can use to iterate over all the elements of the Fibonacci sequence. And it's an infinite sequence, so I can just keep on going by asking for the next item. So I can code that up. I can just say, okay, Fibonacci is a function. I declare some local state like pre and cur, which refers to the previous and the current Fibonacci number, so I can generate the next one. And the function actually returns an object with a next method. And whenever I call that next method, I get back the next value, the next Fibonacci value in the stream. And it also returns a little sort of flag, a DON flag that tells us whether or not this is the last item in the sequence. And since this is a infinite sequence, I just return false here. It's never going to end. And then the way I can consume that iterator in ECMAScript 5, for instance, is I have to explicitly sort of get the iterator, call the next method, check with a while loop, a standard while loop, whether the DON flag is false or not. And if not, I ask for the value, do some logic, and then I have to explicitly update the iterator. Okay, this is sort of similar to in Java before they had the special for iteration syntax. You had to sort of write a manual for loop and call next and has next on the iterator. It's very similar. Okay, so in ECMAScript 6, at least, we have a new for-of iterator. So JavaScript already had the for-in loop to enumerate the properties of an object. Now for-of loop actually requires the right-hand side here to evaluate it to something that returns an iterator, and then it will just exhaust that iterator. And the benefit being you can also use all the traditional imperative control logic, break, continue, return, and so on. Okay. So what this for-of loop does is it sort of abstracts away the iterator protocol into the for-of loop. You don't see sort of the actual protocol being used. Now, so that's great. But if you look at the generating function, Fibonacci here, it still needs to know about the details of the iterator protocol. It needs to know that it has to return an object with a next method, and that next method has to return an object with a value and a DON field, and so on. So it's quite cumbersome to write. So the flip side of iterators are an abstraction called generators, which are actually sort of, there's a lot of influence here from Python. So what is a generator? Well, it helps you write functions that return iterators. And so over here, I've taken the generating function of Fibonacci in ECMAScript 5. I rewrite it in ECMAScript 6. And what has changed? Well, notice the little asterisk here. you should sort of think of it as a cleany star. Like now, instead of a function, you call it and it returns a single value. You call it and it returns an iterator that produces 0 or more values. Okay, and then inside of this, these functions marked with that little asterisk inside these generator functions, you can use a new keyword called yield to sort of return a value to your caller, but at the same time sort of suspend execution of this function until the caller asks for the next element in the sequence, and then you sort of continue from there. Okay, and the really nice thing about this is that we can abstract all the control flow logic of the iterator protocol, just like the for-of loop did for iterators, because if you look at the code over here, there is no notion of all of these sort of iterator protocol fields. And it also, as you can see, this sort of infinite sequence of Fibonacci numbers, I can just express it as an infinite for loop. Okay, so it's really much more concise to write code that generates multiple values. And hopefully, through the introduction of iterators and generators, we'll be seeing more and more JavaScript libraries that make use of this fact that you can do sort of infinite streaming libraries. So, okay, a third control flow abstraction I wanted to talk about that has become tremendously popular over the last few years in JavaScript are promises. So promises have to do with simplifying asynchronous control flow. Okay, so if you think about JavaScript, one of the things that are fairly unique about JavaScript is that most of the environments in which the scripting language is embedded are environments where all of the interaction with the outside world is asynchronous. You read a file, it's asynchronous. You talk to a network socket or you do a remote HTTP call, it's asynchronous. You render something on the UI or react to user input, it's asynchronous. So if you look at, for instance, if you would program in something like Node.js, a server-side platform where you can do file I/O, the way you would read a file is you would call a read file function, you give it the name of the file, and you have to provide it a callback that will be executed when the file contents has been read from disk, and then either you will get an error or you get the contents of the file. Okay, so this is a sort of standard pattern to always provide the error object as the first argument of the callback. You can then dispatch on that. If the error is defined, you handle the error case. Otherwise, you handle the success case. Now, ECMAScript 6 with promises allows you to rewrite this. So a promise is sort of like a placeholder for a value that is yet to be computed in the future. And rather than your functions taking callbacks, you can just have them take the normal arguments without the callback. But rather than having the function return undefined, the function can now return something. It returns a promise for the contents of the file. Okay. Now, what can you do with a promise? Not all that much. One of the most important things you can do with a promise is you can register using this done function here 2 callbacks with that promise. You can register a success callback that gets the contents of the file, or you can register optionally an error callback that you can use to handle the error case. Now, if you look at this, you might think, so what? What have we gained? I mean, if anything, maybe this code is even clearer to read than the bottom one. The big deal is that this then function returns another promise for the result of whatever these 2 blocks compute. So in fact, what I said earlier about then registering 2 callbacks with the function, that's not true. You're not registering a callback. A callback never returns a value. You're registering a transformation function that takes a promise, gets the value out of that promise, does something with it, computes a new value, and what you get out of the whole thing is a promise for the new value. So you get this fluid API where you can chain multiple operations one after the other. JavaScript developers, of course, know this from jQuery, which is structured along very similar lines. Okay. And so if you look at this sort of, if you zoom out a bit and you look at more complicated real-life usage of asynchronous control flow, you often get these examples where, say, you have to execute 4 steps in sequence, like you might want to do an HTTP request and you get back a value, and then that one you want to store in a database, so you have to do another asynchronous call and so on. So if you do that with callbacks, you end up with these sort of rightward drift in your code where you have to sequence these things by nesting, and then at each level of nesting, you also have to always explicitly handle the error case. You're actually encoding sort of the error monad explicitly in the code, if you will. With promises, you just, rather than your step functions taking a value and a callback and returning undefined, they take a value and return a promise. This allows you to chain them sort of linearly in a sequence. And then, for instance, you might add, catch is a utility method that just registers an error handler. And the beauty of this is also that, say, step 3 throws an exception, then this will just bubble through all the subsequent steps, and you handle the error here. So this is sort of like the traditional way that try catch also sort of implicitly bubbles up exceptions up the call stack. So you regain that feature. Okay. So promises actually already exist as a library in ECMAScript 5, Q and Bluebird being two very well-known ones. So one question you might ask is, if they can be implemented as a library, why would you want to standardize them in the language? And so one of the things, interesting things about promises is that there was wide agreement in the community that we needed something like this, but there was wide disagreement on the very specific details on, for instance, how this then method should behave. Okay. And so there was various specifications floating around and various libraries doing other things. And it wasn't until a spec for promises called promises/A+ arrived on the scene, which gathered enough momentum from the community of JavaScript developers working on promises. So it wasn't until that spec came about that there was enough consensus, enough rallying behind a single spec, that the committee decided, okay, now is the time for us to also introduce promises into the platform based on this specification, essentially. So they would immediately be interoperable with the wide range of libraries that were already out there. Okay. Now, the big benefit of putting promises in the core API is that now parts of the JavaScript standard itself, of the core API, the core libraries of JavaScript, can also start using promises rather than requiring callbacks. To give you one example, modules come with an extensive module loading mechanism, and module loading is asynchronous. So what are you going to do? Are you going to write an API that takes callbacks? Or now that we have promises in the language, that API can just return a promise for the loaded code. Okay. So the other thing is that other standards bodies like W3C, for instance, which standardize the interface between JavaScript and the browser, for instance, the DOM, the document object model, they have a lot of use cases where they need asynchronous interaction. And with promises being a part of the language, they can rewrite a lot of those APIs to also use return promises rather than taking callbacks. So I've given you this very short list of features, classes, modules, iterators, generators, and promises, and that's I don't have more time to go into the details of other features, but I can recommend, if you're interested, a long list that was written up by Luke Hoban, who is a representative of Microsoft on TC39. Just go to git.io/ES6 features. He has a very nice summary of all the features in ECMAScript 6 with a short description of their use and their context. So I'm going to transition to a third part of the talk where I want to talk a bit about how we navigate this transition period that we find ourselves in today. Because I mentioned earlier, ECMAScript 6 was published in June of this year, and you shouldn't expect the way this works is not that the spec is released and then next month or next day all the browsers upgrade and you get the 6th edition. The difference in, let's say, complexity between the two specs is way too big for that to happen. Okay, so instead what we see is sort of like, I don't know if that's readable in the back, there's sort of a vague cloud where actually there were already some features of ECMAScript 6 that have been around in browsers implemented for a couple of years. And there will be other features that will be rolled out over the next few years. And there will probably be a long tail with some features taking another couple of years before they get widely adopted. And in fact, there's this very nice table maintained by Yuri Zaitsev, sort of where he wrote little unit tests, let's say, that or feature tests that test whether a feature is available on a certain platform. Those are like the rows that you see here, and then the columns are different platforms, like browsers, mobile browsers, server-side platforms, and so on, different versions of that. And you get this interesting patchwork where you see that some platforms implement a feature that's green. If they don't implement it, that's red. And the way the mental model you should have is that over time we will see this table growing greener and greener. At least that's the hope. Now, if he also maintains this table for ECMAScript 5, and if you look at that, for instance, you get this picture where almost everything is green. There are some red spots here, but actually those are not the platforms, like the major platforms. So there will always be platforms, of course, that that will not upgrade or will not implement all of the features, but the most important ones actually today, they're all fully ECMAScript 5 compatible. So what are we to do with, given that this is the current situation? It would be extremely bad for if you're in a development team and you're doing JavaScript development. What the bad thing to do would be to start doing these feature tests and say, if this feature is available on this platform, let us use it. Otherwise, let's fall back and do something else. No, that's terrible. One of the recommended way of working with ECMAScript 6 today is to simply use a compiler that compiles from ECMAScript 6 down to ECMAScript 5 if you want to target ECMAScript 5 platforms. And there's actually two sort of fairly mature projects. So one is Babel, which is really an ECMAScript 6 to ECMAScript 5 compiler with a lot of community support, a lot of also plugins. It's extensible. You can sort of introduce your own code transformations. It also supports JSX, so if you're familiar with Facebook's React framework, it will compile away that syntax for you as well. And so that's really taken off in the last few years. It's quite a reliable compiler. It also, interestingly, it has these two modes. It has one mode where the code that it outputs is almost like the code that you would have written in ECMAScript 5, like I shown you previously on the slides with the desugaring of classes, let's say. And there's also a sort of stricter mode where it will try to really faithfully implement the ECMAScript 6 semantics, but that often requires that often means you can't do a sort of direct translation anymore to ECMAScript 5. Then there is TypeScript from Microsoft, which is not technically an ECMAScript 6 to ECMAScript 5 compiler. It's actually, TypeScript is sort of more of a superset of ECMAScript 6. It's not strictly a superset. It doesn't have all of the ECMAScript 6 features yet. But at least the longer term goal, as far as I'm aware, is to align with ECMAScript 6. So TypeScript actually, it's very similar to the call we just heard with Hack. It's sort of, how do we introduce more static type safety in JavaScript while still maintaining compatibility with the huge amount of code that is already out there. So TypeScript adds optional static typing, but it also, for instance, adds like the class syntax for ECMAScript 6 and many of the other features, and it will just also compile them away to ECMAScript 5. So on the server side, there have been a lot of interesting developments over the past year. So of course, Node.js is the go-to server-side JavaScript platform today. There's been an interesting sort of fork happening of the Node.js project where some of the core developers of Node forked Node.js into a project called IO.js, where the goal was to actually move a lot faster. So Node was on a fairly slow release schedule. It was still based on a fairly old version of V8 that didn't yet include many of the improvements of ECMAScript 6. So they moved this forward quite rapidly. And then just a few months ago, Node version 4.x got released. And that is basically a sort of join again of the progression that was made in IO.js with the old code base. So Node version 4 or bigger is actually based on a more recent version of Google's V8 engine, where many of the features of ECMAScript 6, and in particular features like classes, promises, iterators, even generators, they're all in there, enabled by default. So if you're developing on Node version 4 or later, you actually get a lot of features of ECMAScript 6 out of the box without having to do anything for it. Okay, so the last part of the talk, I want to mention a little bit about what is beyond ECMAScript 6. What is the committee working on today? And so there's quite a number of proposals in the pipeline. If you want to see the full list, you can go to TC39's GitHub page, and they're all documented there. Over here, I just show you the ones that are in stage 2 and stage 3. So there's a sort of staging for proposals where one is basically just it's a strawman proposal, and stage 4 means it's sort of feature complete, and stage 2 and 3 basically means that the committee has decided, yes, we want this feature in the language, we just need to nail down the details, have prototype implementations, and so on and so forth. So there's many interesting things, and the scope of these features is tremendously different. Like exponentiation operator is just adding the star operator so that you can do, it's a better syntax for math.pow to do exponentiation. But then there's also like simd.js, which is a very large addition to enable simd instruction support in JavaScript. There is one feature I want to highlight out of this table because I think this will be the killer feature of ECMAScript 7 or ECMAScript 2016, which are async functions. So, and again, they have to do with improving asynchronous control flow. So, async functions are actually a feature that was largely influenced by a similar feature from C#5, which allows you to write asynchronous code in direct style, using direct style control flow without callbacks. So if we look back at that promisified example that I've shown you earlier, where we sort of have these 4 steps that we need to execute in sequence, and then we attach a catch handler. This is better than the callback-based version, but you're really sort of the problem is that you have this sort of monadic control flow. You have to wrap everything in a function. By doing that, you sort of lose the ability to use traditional control flow operators like for loop, break, continue, return. You can't really do that. So with async functions, you just annotate the function as async. You can write direct style code that calls out to some asynchronous operations like these 4 function calls, and you just introduce a new keyword called await, which essentially will, this function over here will return a promise, and then await simply waits for that promise to get a value, sort of suspends the function execution until that promise has a value, and when it gets a value later on, then the function is scheduled for execution again, and it will just continue from that await point. And this whole sub-expression over here is replaced with the value of the promise, okay? And that allows me to chain these 4 function calls using just semicolons, just using, by calling these in line. And interestingly also, if you look at the error handling pattern here, I can just use a standard try-catch operator or statement to catch any exception that happens in one of those 4 cases. Okay, and the same thing goes for like for loops. I can do asynchronous code that has for loops, while loops, return, and so on. That all now just sort of composes cleanly. Okay, so that's for JavaScript, where almost everything you do is asynchronous. That's a big win. Now, if you heard my explanation about the await keyword, I mentioned that it sort of suspends execution of a function and then continues later. Doesn't that sound awfully similar to what yield does with generators? Well, indeed, so people have found out how to sort of abuse generators, if you will, to implement the async await functionality. And so if you want to get this running today, something you can do, for instance, on the latest version of Node, there's a library called CO, which you basically give a generator, and what that CO function will wrap that generating function that returns an iterator into a function that returns a promise for the last value in that iteration. Okay, so it sort of is an adapter that mediates between the iterator protocol and the promise protocol, so that I can use the yield statement as if it were an await statement. Okay, and so that means I can do in ECMAScript 6, I can actually already benefit from all of the advantages of the direct style control flow that async functions would provide. Okay. In fact, you can even have async functions in ECMAScript 5 because thanks to Facebook, actually, they have a library called Regenerator, which basically allows you to compile a function that contains yield statements, so a function that is a generator. It compiles it down to a state machine that basically sort of remembers all the exit points of the function, and when you enter it again, it just switches, or it jumps right at the point where it's executed previously. So it's really the transformation here it's really a compiler transformation. It's not just a simple rewrite. Okay, you have to take care of all of the edge cases that return, continue, break, and so on that is introduced. You have to compile that into a state machine. So of course, if you end up with bugs, be aware that you will end up debugging this code over here. So that's the pain point. But at least you can have the benefit of a direct style control flow and have your code running on browsers today. Okay. There's also a plugin for Babel that allows you to immediately already use the async await syntax and have it compile down to the state machine without having to worry about the intermediate generator hack, let's say. Okay. So it's about time for me to wrap up. So the messages I want you to take home is that ECMAScript 6 is a major update to the JavaScript language. I would say it's the biggest update to the language since its birth in around 95. So we're in a transition period today where some browsers or platforms already implement part of the spec, but not yet everything. Expect the engines to upgrade gradually over the course of the next few years. To navigate this transition period, use a compiler to compile your ECMAScript 6 code down to ECMAScript 5 code, but so that you can actually start using ECMAScript 6 today. So thanks a lot for your attention. I would be very happy to answer any remaining questions. Thank you.